a lot of properties for materials to use, and here we listed some of the most important requirements you should check when you start working. First of all, of course, this is a very simple, easy one. Biocompatibility should be a given of the material. Of course, when you look for commercial things available, this is already checked. But if you start with your own materials and your own ideas, be aware of this. Maybe require some samples beforehand and do some own tests if you do not find something in the literature about biocompatibility. Then you should also check if the material leaches into your cell culture. If polymers, especially for soft polymers, can be set free and start to interact with your cells, that can have a negative influence on them. Of course, materials, you can also check if there's a potential for cell ingrowth. Maybe you want this, that your cells interact with the material. It is often desired for hydrogels in complex cell models. Here. And if the material gives you possibilities for chemical modifications. This is a quite nice feature that you should be aware of. So if you can link something to the surface of the material, or if even the material is suitable for micropatterning, so for producing artificial small-scale surfaces that direct maybe your cell growth or cell functions. And one of the big issues we are also addressing today is, of course, adsorption of compounds. Especially this is a very hot topic when you want to use your model, not just to answer maybe biological questions, but really want to use to look into therapeutic options to treat diseases. So compound screening of classical small molecules, for instance, but also new applications like biologics by tri-specific antibodies and so on. What can also be a nice feature is flexibility of the material. And you should also be aware of oxygen permeability, especially when you want maybe to build up models to study host pathogen interaction, and your pathogens need anaerobic or aerobic conditions. You should check this if this is possible with the material. Other properties that have more impact on downstream analysis, for instance, is optical clarity. Can you use your platform under a microscope and check your cells, or do you have to wait until experiment is finished and then be surprised, oh no, there was no tissue anymore. So this is a good point. Also tunable fluorescence of the material and accessibility of the biological sample. Can you recover your tissue from the device afterwards as a whole or as single cells? Or does an attempt to recover the tissue result in destroying your model? And if you're looking more into scaling up your production because you have a large lab and a lot of people who want to work with it, or you even also want to provide your platform to others, commercial factors come also into place, like how is the costs to produce your devices. It's often also a big issue for academic labs who have to look for funding. How easy is it to fabricate this for your employees? and how easy is the prototyping, so changing geometries, trying different things out. There are some materials that are more suitable for this than others.